In this lecture, we will be covering Chapter 11 in your statistics book, Presentation of Data. A set of raw data may not necessarily provide a user, such as an administrator or an HIM professional, with information that can be easily interpreted. Descriptive statistics are the most common type of statistics that the health information professional will encounter or will be responsible for producing. Descriptive statistics describe populations, which can be patients, nursing units, or hospital departments. As mentioned in Chapter 10, these statistics provide an overview of the general features of a set of data. Statistics can assume a number of different forms, the most common being tables and graphs, many of which we will look at in this chapter. Before choosing the appropriate method for displaying data, it is important to determine what type of data we have and what would be the best display method. There are 4 types or scales of measurement of categorical data. Those are nominal, ordinal, ratio, and interval. Nominal data are the lowest level of measurement. The word nominal means pertaining to a name. In the nominal scale, observations are organized into categories in which there is no recognition of order. Examples of nominal data include true-false, male-female, maybe type of insurance carriers, or patient occupations. Often numbers are used to represent categories. For example, a male may be listed as the number 1 and a female as number 2. Or persons may be grouped according to blood type, where a value of 1 represents blood type A, and so on. The sequence of the values is not important. The numbers simply serve as labels for a piece of information. Ordinal data are types of data where the values are in ordered categories. The word ordinal means to put something in order. On the ordinal scale, only the order of the numbers is meaningful, not the numbers themselves. This is because the intervals or distances between categories are not necessarily equal. For example, head injuries can be classified according to level of severity, where the number 4 is fatal, 3 severe, and so on. A natural order exists among the groupings, with the largest number representing the most serious level of injury in that example on the previous slide. However, we could reverse the order. There is no rule on that, obviously. There's no reason why one couldn't represent fatal and that order could be reversed. And the intervals between ordered categories are not assumed to be equal. Interval data includes units of equal size, such as IQ results. There is no 0 point. The most important characteristic is that the intervals between values are equal. An example of interval scale is time. Time is measured, as we know, in 24 hours in one day. The time between each hour is the same. So, for example, there's 60 minutes between 1 and 2 a.m. and also 60 minutes between 5 and 6 p.m. Ratio data, or scale, this is the highest level of measurement. There is a defined unit of measure, a real 0 point, and the intervals between successive values are equal. Ratio data may be displayed by units of equal size placed on a scale starting with 0 and thus can be manipulated mathematically. For example, if we look at age, the difference between any 2 years would be the same. There is a 0 point, and that 0 would mean absence of an age or a birth. Someone who is 100 is twice as old as someone who is 50. There are 2 types of numerical statistical data. They are discrete and continuous data. Discrete data are finite numbers. That is, they can have only specified values. The number of children in a family is an example. A family can have 2 or 3 children, but they cannot have 3.5 children. The numbers have to represent an actual measurable quantity. These are just some more examples of discrete data. Again, these must be specified values. In discrete data, a natural order exists among the possible values. In the example of the number of times a woman has given birth, a larger number indicates she has more children. The difference between 1 or 2 births is the same as the difference between 4 and 5. For the most part, measurements on the nominal and on the ordinal scales are discrete. Continuous data represent measurable quantities but are not restricted to certain specified values. A variable that is continuous can take on a fractional value. For example, a patient's temperature may be 102.6. Another example is height or age. The only limiting factor for a continuous observation is the degree of accuracy with which it can be measured. For analysis, continuous data are often converted to a range that acts as a category. For example, we could categorize a range in ages. Measurements on the interval and the ratio scales can be grouped. Interval and ratio variables are continuous. Now we're going to move on to actually displaying our data. A table is an orderly arrangement of values that groups data into rows and columns. Almost any type of quantitative information can be grouped into a table. Columns allow you to read data up and down, and rows allow you to read across. The columns and rows should always be labeled. Many word processing or spreadsheet programs offer you assistance in creating tables. There are a number of advantages to using tables. Those include more information can be presented, exact values can be read to retain that precision, supportive details can be provided, less work and fewer costs are associated with the preparation, and flexibility is maintained without distorting your data. The essential components of a table include a title. The title should explain as simply as possible what is contained in your table. A stub heading, the title or heading of the first column. We also need column headings. Stubs are the categories on the left-hand side of the column. Cells, we need information in our cells. That's the information formed by intersecting columns and rows. And also a source footnote for any data should be identified in a footnote. This is an example of a table. There are also several examples in your textbook on page 200 and 201. A frequency distribution shows the values that a variable can take and the number of observations associated with each value. A variable is a characteristic or property that may take on different values. For example, third-party payers, discharge service, or admission day are examples of variables. There are some general rules for choosing the classes or categories into which data are to be grouped and the range of each. Do not use fewer than 5 or more than 15 categories. However, that choice depends mostly on the number of values that are going to be grouped. Categories should be well defined. Choose categories that cover the smallest and the largest values and do not produce gaps between your categories. The categories should be mutually exclusive, where each observation is grouped into one and only one category. Avoid successive classes that overlap or have common values. Whenever possible, make the classes cover equal ranges or intervals of values. These ranges should be made up of numbers that are easy to work with. Graphs of various types are the best means for presenting data for quick visualization of relationships. They often supply a lesser degree of detail than tables. However, when data is presented in a graph, it can be helpful in displaying statistics in a concise manner. There are advantages to using graphs. They grab the audience's attention and are easy to understand. They can easily show trends or comparisons. Graphs should be easy to read, simple in content, and correctly labeled. The presentation of data in a graph is an excellent way to convey the message you want to get across. When creating graphs, you should follow these general guidelines. The title must relate to what the graph is displaying. Follow the same general guidelines as for the title in graphs as given in that we talked about in tables. When several variables are included on the same graph, for example, males and females, each should be identified using a legend or a key. Categories should be natural. That is, the vertical axis should always start with 0. The scale of values for the x-axis reads from the lowest value on the left to the highest value on the right. The scale of values for the y-axis extends from the lowest value at the bottom of the graph to the highest at the top. Scale captions are placed on both axes to identify values clearly. These are simply titles placed on each axis to identify the values. Graphs should emphasize the horizontal. It's easier for the eye to read along a horizontal axis from left to right. Also, graphs should be greater in length than they are in height. A useful guide is to follow the 3/4 high rule, which states that the graph's height, or the y-axis, should be 3/4 of its length, or that x-axis. The exact reference to an outside source should be given as a source footnote. Bar graphs, or as some people refer to them as bar charts, are appropriate for displaying categorical data. The simplest bar graph is a one-variable bar graph. In this type of graph, the various categories of observation are presented along the horizontal or the x-axis. The vertical axis, or y, displays the frequency of the data. Data representing frequencies, proportions, or percentages of categories are often displayed using bar graphs. A grouped bar chart is used to display information from tables containing 2 or 3 variables. This is an example of a bar graph, just a very simple one. There are many other examples in your textbook which you should review to get some different examples of what some of the bar graphs can look like. Pie charts or pie graphs, that is a method of displaying data as component parts of a whole. It is an easily understood chart in which sizes of slices of pie show the proportion contribution to each part. Use a pie chart when you want to show a category's percent of a total. A circle is divided into sections or slices. These represent percentages of the total, which is 100%. To make a pie chart, include all categories that make up the whole. Therefore, your data must be converted into percentages unless you're working with a computer software that would convert your numbers to percentages for you. Pie chart wedges should be shaded or colored to help differentiate the different sections. This is an example of a pie chart. Again, there's more examples in your textbook. A line graph is often used to show data over time. For example, days, weeks, months, or years. The x-axis shows the time period, and the y-axis shows the value of the variables. A line graph consists of a line connecting a series of points. Line graphs also allow for several variables to be plotted. Line graphs are also referred to as run charts. This is an example of a line graph. Again, there is other examples in your textbook reading. A histogram is a graph used to display frequency distributions for continuous numerical data. Histograms are created from frequency distribution tables. They look similar to bar graph, except that all the bars in a histogram are touching because they show the continuous nature of the distribution. In a histogram, all the bars should be equal width. Ordinarily, in constructing a histogram, there should not be less than 4 and usually never over 12 bars or classes, and the frequency groups should not overlap. This is an example of a histogram. And again, for this as well, there are a few other examples in your textbook. A frequency polygon is similar to a histogram in that it is a graph depicting the frequency of continuous data. However, a frequency polygon is in line form instead of bar form. The advantage of a frequency polygon is that several of them can be placed on the same graph to make comparisons. A frequency polygon uses the same axes as the histogram. That is, the x would display the scale of the variable, and the y-axis displays the frequency. A dot is placed at the midpoint of the class interval or frequency. A line is drawn from one point to the next and connects the dots. Because the x-axis represents the entire frequency distribution, the line starts at 0 cases and is drawn from the last frequency to the y-axis to end with 0. This is an example of a frequency polygon. Once again, there is more examples in your book, and it's a good idea to go through and look at each of those. You will be looking at different graphs and interpreting those on questions in your RHIT exam if you're an HIT student and plan to sit for that exam. That will be one of the portions, is being able to interpret a graph. So take some time and go through your textbook reading and make sure you understand how each of those graphs is composed, what it is measuring, and if you have questions, you can contact me. A pictogram, that's an attractive alternative type of bar graph that uses pictures to show the frequency of data. For example, if you want to show the top 5 cancer site deaths, you might use stick people. If you need to show exact numbers, a pictogram will probably not be a good choice for your presentation. However, they're very good at catching the attention of your audience and will give them a good sense of data. This is an example of a pictogram. Again, you can see that in this example, they use little apples to represent one apple on the graph equals 2 apples. A scatter diagram is also called a scattergram or a scatter plot. It's used to show the relationship between 2 numerical values. The scatter diagram is used to determine whether there is a correlation or relationship between 2 characteristics. Correlation implies that as one variable changes, the other will also change. This does not always mean that there is a cause and effect relationship between 2 variables, because there may be other variables that could cause the change. If the 2 characteristics are somehow related, the pattern of points will show a tight cluster in a certain direction. The closer the points look, the more the 2 characteristics are likely to be correlated. And you can look at figure 11.13 in your textbook. The slope of a line can be either positive or negative. Positive means that small values of the x-axis correspond to small values of the y, and large values on the x correspond to large values on the y. Then there is said to be a positive linear relationship. If there is a negative slope, that means small values on the x-axis correspond to large values on the y, and the large values on the x correspond to small values on the y, and that is said to be a negative linear relationship. This is just an example of what a scatter diagram could look like. Writing reports for your workplace is not the same as writing an article for a journal or preparing a report for an assignment in one of your courses, but the goal is the same. Communication is the goal, and it is achieved when you write your report in the style that really the audience would prefer to see. Often, healthcare administration will let you know how reports should be prepared and presented within your facility, or you could review previous reports that have been given to specific committees or administration. These are some general guidelines to think about when you are preparing a report. Always make sure there is a title for formal reports or one with many graphs or tables. Be sure to include a table of contents so the user or the reader can easily refer back and forth. Include tables and graphs. They summarize data and they are visually attractive to the reader. Be sure and determine the type of audience to help you decide what you want to include in the report. Prepare a narrative report if you need more understanding. Those can include historical data, factors that influenced data, and make sure to include any sources that you used. And probably most importantly, make sure the data that you are using and representing is correct.